So, good afternoon, class. We're on the Angles of Polygons 7.1. So the first definition is already written for you. It's over diagonals. Thinking of diagonals as you're writing this down, polygons, I think poly is more than one. So think of pretty much any shape that has more than one side. So this can be quadrilaterals, which we'll get into as well, triangles, heptagons, which are seven-sided, and etc. And so our first definition is a diagonal, which is a segment that joins two non-consecutive vertices. And think vertices are like your corners in elementary terms. So then we're on equilateral polygon. So we talked about equilateral triangles. And equilateral, if you know that keyword that's in equilateral, equal, and then the lateral part is sides. So think equal sides polygon. So in definitions terms, this is where all sides, pardon my pen, of a polygon are congruent. So remember, congruent means that they're all equal as well. So all sides of a polygon are congruent. And so now on to our next definition, which is equiangular. So think equal is still equal, and then angular sounds very much like angles. So think equal angles, like an equiangular triangle. Polygons that are equiangular is where all angles of the interior of a polygon are congruent. So now these are all the angles on the inside. So angles of the interior or inside of a polygon are all equal or congruent to each other. So pardon me one moment as I grab a different pen. Okay, let's see if this one works. Now we're onto a regular polygon. A regular polygon just means that they are both. This is a convex polygon that's both equilateral and equiangular. Okay, so those are the four definitions that we've gone through today. So now we're on to our theorems. Now our first theorem is the polygon interior angles theorem. So remember we talked about you can have equal angle. Anytime we're talking about the angles, most of the time we're going to talk about the inside. So then it's interior, so that means the inside of the polygon. So polygon, remember, it means many sides. Many sides, many vertices. So our first theorem says the sum, which means the add, of the interior angles of an n-gon, so this can be 7-gon, 11-gon, 12-gon, 24-gon, is n minus 2 in parentheses times 180 degrees. So for example, we have six sides or six corners, six vertices. So that means n is the number of vertices or number of sides. Okay, and so if that's the number of sides or vertices, if we want to find use the theorem to find the sum of it, we would take n minus 2 times 180. Okay, so you put this in parentheses or put the little dot for multiplication. Either way is fine. So n is 6. So we have 6 minus 2 times 180, and 6 minus 2 is 4. So 4 times 180 is 720. So that's one example. I'm going to give you several examples on this one just so it'll be a lot easier to understand. So let's say we had a 13-gon. So we know n-gon, so how many sides does this one have? Or what would n stand for? N would actually be 13. So all we have to do is plug it in to our interior angles theorem formula. So n is 13, so 13 minus 2 times 180, and this equals 11 times 180, and so I get 1,980 degrees. Now our last example I'm going to give you is, what if we want to find n? What if we want to find n, which means the number of sides, and we're given the sum already. So say our sum is 900 degrees, and we need to find n. So we know that n minus 2 times 180 is normally our formula. And usually you're given that entire sum, which is usually our big number. In this case, it would be 900. And then you would solve for n. In order to solve for n, I need to get n by itself. So think of this as its own variable. So how do I get rid of 2, or say n, times 180? Well, I'd have to divide. So I'm going to divide both sides by 180. And so then I'm left with n minus 2 equals 900 divided by 180, which is 5. And then I'm going to add 2 to both sides, and so n equals 7. So that's the number of sides our polygon has. And if we want an actual classifying this triangle or classifying this polygon, it's called a heptagon. So that's a way to find n and its number of sides. So let's try another, move on to our next page with a different theorem. So our next theorem is a corollary, actually, and it's to the polygon, but this time we're talking about quadrilaterals. So this is the sum of the interior angles of a quadrilateral is 360, and the key word there that's going to help is quad, and quad means 4, so think 4-sided. And so this only works for 4-sided polygons. It's called a quadrilateral. So that's a square, trapezoid, rhombus, rectangle, etc. Anytime it's 4-sided, parallelogram too, they are called quadrilaterals, and these will always add up to 360. So let's do an example. So let's say I had a trapezoid. Oh, it is not drawn to scale. So let's say I had x degrees, 108 degrees, 121 degrees, and 59 degrees. And I wanted to find x. Well, I know the sum of the interior angles has to give me 360. So just like triangles, they have to add up to give me 180, well, quadrilaterals have to add up to give me 360. So all of these should give me 360 degrees. So to solve for x, I have 108 plus 121 plus 59 plus x should give me 360 degrees. So adding them up together, like terms, I have 288 plus x. And then when I subtract 288 from both sides, that means my missing angle, x, is 72 degrees. Alrighty, on to our next theorem. We have the polygon exterior angle. So this was talking about the stuff on the outside. Okay, and this is going clockwise, kind of like a circle, so that's why you see 360 again. So the same rules apply. So the sum of the measure of the exterior angles of a polygon, so it doesn't have to be a quadrilateral this time. There can be any many-sided figure, but if you're looking for the exteriors, they're going to add up to 360. So I'm going to draw an example. Please bear with me as I draw it not drawn to scale. Alright, I'm going to extend every arrow going clockwise. Okay, so let's say I had 62, 35, 69, 41, 58, and 5x degrees. and I need to find x. Well, I know the sum of the exterior angles is going to equal 360. Okay, so that means I'm going to add up all of my sides, and they should equal 360. So I have 62 plus 35 plus 69 plus 41 plus 58 plus 5x give me 360. So make sure I'm adding like terms. So I have 265 plus 5x, and when I subtract 265 from both sides, I'm left with 5x equals 95. Dividing by 5, I have x equals 19. Alrighty. So moving kind of fast, but no, you can always pause for any of this video if you need time writing. But I'm trying to make sure it's not as long as 40 minutes. So let's go to the other side, and we're going to do the extra practices. So this is asking the sum of the measures of the interior angle. So that means we're going to use the 7.1 theorem. So the sum of the interior angles of the polygon, okay? So remember, it says polygon using more than one, and we're talking about the sum of the interior. And so this is knowing we're going to use 7.1 theorem, which is where it's n minus 2 times 180 to find the sum. Please pardon that it does go in and out sometimes. So please bear with me as the focus does go in and out. So I have an octagon. How many sides and vertices does an octagon have? Well, that would be 8. So that means n equals 8. So all I have to do is plug it back in. So we have 8 minus 2 times 180, which is 6 times 180. And so the sum of the interior is 1,080 degrees. And so we'll do the same thing for 2 and 3. So we have a 15-gon, and so now we can have n-gon sides, so that means n equals 15. So I have 15 minus 2 times 180. 15 minus 2 is 13, and so I'm left with 2,340 degrees. And the same with number 3. 24 minus 2 times 180 gives me 3,960 degrees. Alrighty. So in 4, 5, and 6, now it's asking for the number of sides. You're still using the sum of the interior angles, but you need to find n. And we're already given the big number, or the interior. We're already getting the sum of those. Now we need to find the number of sides. So we're still doing with n minus 2 times 180. But this time we're already given this number, and we have to find n. Okay? So in this case, this is like the previous example. We have n minus 2 times 180 equals 900. So we have to divide from 180. So n minus 2 equals 5. Add 2 to both sides, so n equals 7. And it also says classify the polygon, so it is a heptagon for 7-sided. That's heptagon. So we'll do the same thing for 5 and 6. So I have n minus 2 times 180 equals our big sum of the interior angles, which is 1,620. I'm going to divide both sides from 180. So I'm left with n minus 2 equals 9. When I add 2 to both sides, n equals 11. And there really isn't a name for 11-sided figure, so we just call it an 11-gon. Kind of like how we said 15-gon and 24-gon. And we'll do the same thing for number 6. So I have n minus 2 times 180 equals 2,880 degrees. I'm going to divide from 180. So I have n minus 2 equals 16. And when I add 2 to both sides, n equals 18. And there's not a name for an 18-sided figure, so we call it an 18-gon. Alrighty, so these two deal with 7.1 theorem, where you're finding the number of sides or the sum of the interior angles. So let's move on to the bottom 4. It says find the value of x. So, finding the value of x, it helps to know how many sides or how many vertices do we have. In this case, we have 4. So a 4-sided figure is actually called a quadrilateral. So this means we're not really going to use our n minus 2 squared because quadrilaterals, their interiors add up to 360. Remember, that's the corollary we talked about. So that means these all must add up to 360 degrees. So I have 65 plus 95 plus 45 plus x equals 360. When I add like terms, I end up with 205 plus x, and I subtract from both sides, x equals 155 degrees. Alrighty, for number 8 is a little different because I don't have a 4-sided figure. And so we don't know how many degrees it's supposed to add up to. But we can actually use this in order to find out. So how many sides do I have? Or how many vertices do I have? 1, 2, 3, 4, 5, 6. So that means n equals 6. So the first thing I do is I'll use 7.1 theorem. So I have n minus 2 times 180. And we plug in n. And so I get 720 degrees like I did before. So that means every single one of these has to add up to give me 720 degrees now. So now I can add all of them up based on 7.3 in order to get what x is. So I'm going to add x plus 140 plus 130 plus 120 plus 150 plus 90, because note that is 90-degree angle here, to equal 720. And I'm going to add like terms. I get 630 plus x, and when I subtract 630 from both sides, x equals 90 degrees. So G is 90 degrees. Okay, so this one's kind of a two-step problem. And we'll do a similar one like this for number 9. So when you're trying to find the value of x, note that your sum, if it's more than 4, you have to use the n minus 2, the sum of the interior angles theorem first. And then you can add them all up to give you your interior, or to give you your missing value. So let's do the same thing for number 9. Let's count how many vertices or sides that we have. 1, 2, 3, 4, 5. So n equals 5. So I'm going to plug it into my n minus 2 times 180 formula. So I have 5 minus 2 times 180. So I have 3 times 180, which gives me 540. So that means each and every one of these has to give me 540. And so I'm going to add up each term. So I have x plus 90 plus x plus 70 plus 100 give me 540. Make sure you add like terms. So I have 2x plus 260 degrees. And when I subtract both sides, I have 2x equal to 280. And when I divide by 2, x is 140 degrees. Now number 10, it deals with exterior angles. And what is always given for exterior angles? Exterior angles add up to 360, just like a full circle. So in order to find x and 4x, I have to add up all of my exterior angles to 360. So I have 4x plus 98 plus x plus 162 gives me 360 degrees. I'm going to add like terms. And I'm going to subtract 265. So I know what 5x equals 100. Oh, I'm sorry, 260. 5x plus 260. And so I'm left with 5x equals 100. And I divide by 5. X is 20 degrees. And that concludes our 7.1 notes over angles of polygons. The next page is a 7.1 practice that we will do during class, but feel free to do it at home if you're confident enough into doing your notes, and we can always do more practice next class. So here's 7.1. Alrighty, thank you so much.